So, as I was saying, we have 2 sections to do this week. Honestly, I thought, you know what? Let's push this back and do a quiz on Friday. If I push this back any further and do extra days, you guys are gonna be like, oh, this is boring. I mean, some of you are gonna say it's boring anyway. But section 6.5 and 6.6 just finish off chapter 6. We are not going to have like a chapter 6 test. Don't worry. So nothing from before break will come back to haunt us. But we have 2 more sections to do, section 6.5 and 6.6. Okay, these have to do with linear inequalities. Linear inequalities. Okay. All right. Now, the first thing that I want to do is take a look at, is this ordered pair a solution to this linear inequality? Is this ordered pair a solution to this linear inequality? Well, how do you tell if something is a solution? What do you do with that thing? Plug it in. If I wanted to check my answer, test out my answer, all you would have to do is plug it in. So where do I plug it? Well, notice here that I've got this inequality. This y is less than 2x plus 1. And I'm given a coordinate, -2, 4. I'm given an x and a y. So all you do is you plug the x in for the x, you plug in the y for the y, and see if this comes out to be a true or false statement. So I say 4 is less than 2 times -2 plus 1. See, for our equations, which is what we just got done with before break, for our equations, you just had to check to see if the left side matched the right side. No, I'm not doing that anymore. I'm testing to see if it's a true statement. The left side does not need to match the right side. This needs to be a true statement, like 4 is less than, okay, I've got 2 times -2 is -4 plus 1, -3. Is that a true statement? Is 4 less than -3? No, this is not a true statement. So therefore, no, this is not a solution. Do the next one. Go ahead and do B. See if 4, 5 is a solution. Ooh, that's a great question. Let's take a look here. So 5 goes in. Is that a true statement? Is that a true statement?
I'm going to say no.
5 is not less than 5. This would be a false statement, so therefore this is not a solution. Okay. I know that this isn't the problem, but what if I changed the problem to say, I guess it is the problem for the part C. What if I changed the problem to say, we're equal to? Now, that would make it a solution. Look, 4 plus 1. Some of you might try to say to me, whoa, it's not less than, though, so it's not a solution. Right? Less than or equal to. Remember that or word means it just would be one of the 2 requirements, right? It just has to be less than, or it has to be equal to. Less than or equal to. So since it's equal to, check, we're good. So this is a solution. Yes, it is a solution. Go ahead and do the last one there. Do example D. Oh, yeah. Is this one a solution?
Yeah.
Is 3 less than or equal to 6? Yes. Some of you may say, whoa, it's not equal to though. That's okay, it doesn't need to be equal to. Less than or equal to, just has to meet one of the 2 requirements, right? So it's less than, so therefore it is, yes, it is a solution. Okay. So this top part of the guided notes here, really all it told us was that, how do we check to see if a coordinate is a solution to the inequality? We don't even know what that looks like yet. We don't even know what an inequality on a 2-coordinate graph looks like. We know what an inequality in a 1-coordinate graph, a number line, looks like, right? Open, closed circle, arrow pointing to the left or to the right, right? We knew what that is, but what happens when we put a y in there? Well, what we do is we really just treat it like an equality. We treat it like an equality, but then we decide whether we shade above or below the line and whether we make the line dotted or solid. So let's take a look here. A linear inequality describes a region of a solution, a region of a coordinate plane called a half plane, divides it into 2 portions. All the points in the region are solutions of the linear inequality. The boundary line is the or equal to. Okay? The boundary line is the equal to. So remember all that time we spent graphing a line? Now what we're going to do is graph the line. Then on top of that, decide whether we shade above or below the line and whether or not we fill in that line. Okay? Now, what does it mean when we shade? When you shade a graph, you're implying that every coordinate that you shade is a solution. Every coordinate that you shade is a solution of the inequality. If I took any coordinate out and ran it back through the inequality, it would give me a true statement if you shaded that. Any non-shaded part of that graph, if you picked a coordinate out of there, would not be a solution. Okay, so let me show you here. When the inequality is greater than or equal to or less than or equal to, take a look here or here. When you have the or equal to, like think about it on a number line, that was the closed dot, right? Closed dot now means filled in line. Okay? Open dot, where we had an open circle on a number line, now is the dotted line on a 2-plane, on an XY inequality. How do we know whether we shade above or below the line? Well, as long as it's in that slope-intercept form, that y equals, or y is less than, or y is greater than, as long as y comes first. If y is greater than or equal to, it doesn't matter. As long as there's a greater than symbol, we shade above the line. If there's a less than symbol, we shade below the line. But we could always pick a test point to see whether a point would be a solution or not. Okay? So here's what we need to do. Are these steps on the back of your guided notes here? Yes, they are. Okay, perfect. I thought so. These are the steps for graphing a linear inequality. First thing, solve the inequality for y. A lot of the times, that's done for you. Okay? Solve the inequality for y. Get y alone on the left side. Step 2, graph the line. Graph the boundary line. We should know how to do that by now. We're now into almost the second semester of Algebra 1. We should know how to graph the line by now. Plot the plot the intercept, use the slope, graph more points. Third, and then we decide whether we fill in solid or dotted line. Third, shade. Shade above for greater than or equal to. Shade below for less than or equal to. Okay, so let's try it. First off, is this solved for y? Perfect. That step is done. Step 1, check. Step 2, graph the line. Okay, what's my slope? My slope is 2. Right? If I wanted to call it 2 over 1, that's fine as well. Remember, that's rise over run. Rise over run. Rise 2, run 1. And then my b value, my y-intercept, is -3, right? So let's graph that line. The y-intercept of -3 puts us right here. Check yourself right now. Did you put it on the x-intercept accidentally? It should be crossing the y-axis at -3, not the x-axis at -3. The y-axis at -3. And then the slope is 2. So what we're going to do is we're going to go up 2, right 1. Up 2, right 1. Now, here is the point where I would fill in the dots. I now have to ask myself, do I connect the dots? Is this line dotted or is this line solid? Which one is it? Solid. The or equal to underneath, right? This portion here means that that's a solid line. That's a solid line. And now I have to decide where I shade. Do I shade above the line? Do I shade below the line? Which one? Well, this is a less than, right? I got y alone, and it was a less than. So I shade below the line. I shade below the line. Now, if you're confused about what's above, what's below, because sometimes when the lines get pretty steep, you can't really tell, you can always pick a test point. You can always pick a test point. For example, should 0, 0 be a solution of this inequality? No. So what would happen if I ran 0, 0 through? It would give me something not true. Let's double check it. Let's just see. Let's check our answer here. 0 is less than or equal to 2 times 0 minus 3. 0 is less than or equal to -3. Is that a true statement? No. And we didn't want it to be. We didn't expect it to be. We expected it to be a false statement. Okay? So we know, okay, it looks like this is shaded on the correct region. On the opposite side of 0, 0. 0, 0 should not be shaded. Let's try another one here. Now, is this one solved for y? No. Okay, so let's practice. Let's solve for y. What's my first step in solving for y, David? Good. Subtract 5x. Subtract 5x. So that gives me 2y, negative 5x minus 8. And now we divide by 2. So y is greater than negative 5 over 2x. 8 over 2 is just 4. Should I have flipped the symbol? I see a lot of negatives happening. Did I miss that? Should I have flipped the symbol? No. I'm good. I don't need to flip the symbol at all because I never divided or multiplied by a negative. I divided by the positive 2. Okay, so here we have our inequality. Again, please don't make it a decimal. The slope, I mean. Please don't make that slope a decimal. The slope is negative 5 over 2. Again, that's the rise over the run, right? And then we have the b value is negative 4. Okay, so my y-intercept is negative 4, and my slope is negative 5 over 2. So I go down 5, right 2. Down 5. No, I was right. 1, 2, 3, 4, 5, right 2. Up 5, 1, 2, 3, 4, 5, left 2. 3, 4, 5, left 2. Now, I'm at the point where I would just make my line. Should I make this a dotted or solid line? Dotted. This is a dotted line because there is no or equal to. Please be clear, people. I do not want to have to guess at whether your line is dotted or not. And then I shade. Okay, be careful here. I have to go with this piece down here. I have to wait until it's solved for y to decide whether I shade above or below. So do I shade above or below? Above. This is y is greater than negative 5 halves x minus 4. So I shade above the line. Kind of caught the line a little bit. That's okay. There we go. You want to use colored pencils? You want to use crayons? I don't care. You can just shade with pencil. That doesn't matter. Let's do one more. I want you guys to practice solving for y. So go ahead and do that. Keep y on the left side for me. Okay, just so we're on the same page, I'm going to go through solving it for y. We subtract the 4x from both sides. We get a negative y plus 2, negative 4x on the right side. We subtract the 2. Negative y is less than or equal to negative 4x minus 2. Now, when I divide by negative 1, what happens to my symbol? And everything gets divided by negative 1. So this turns into y is greater than or equal to, notice how my symbol flipped there, positive 4x plus 2. I hope we would see at the very beginning that it might be easier to just add the y over to the right side from the very beginning, which would have been completely fine. So my slope is 4. My y-intercept is 2. 1, 2, 3, 4 over 1. Down 4, left 1. Should this be a dotted or solid line? Solid. Should I shade above or below this line? Below. Uh-oh. Above. Is it? Above the line, greater than or equal to 4x plus 2. So we shade above the line. Above. Now what does that mean? Again, that means that any shaded point is a solution. Like negative 4 comma 0 should be a solution. Negative 8 comma 0 should be a solution. Negative 4 comma 4 should be a solution. You can kind of check yourself if you'd like to. You can go back in and plug those in. Okay, let's finish off today by now reversing it. Now, what if you started with the graph and I asked you to create the inequality? We know enough about it that we can actually construct the inequality based on just what we see from the graph. All right, so let's take a look here. We know that y always has to be on the left side. Now, let's first decide whether this is going to be a greater than or less than. Is this shaded above or below that line? It's shaded above. What does that tell you about the symbol? Greater than. It's a greater than. Now, do I have to go underneath it and put the or equal to? No. Why not? Dotted line. Right. Okay, now at this point, we just have to pick out the slope and the y-intercept. What's my y-intercept? Good. My y-intercept is 1. My b value is 1. Let's figure out what my slope is. Well, let's try to find another nice point. Looks like it crosses nice right there. So let's figure out what my slope is. Looks like it rises 1, 2, 3. Runs 1, 2, 3, 4. So rise 3, run 4. Is this a positive sloping line or negative sloping line? positive sloping line, up and to the right. So we say 3/4 x plus 1. See, the only new thing is that now we have the shaded region, right? It's not just a line, it's now a shaded region. It's a whole area of points.
Why is it 3/4?
Rise 3, run 4.
Why is it 1? Up 1, to the right 1.
That doesn't cross nicely right there. It's got to be 2. Perfect. Perfect. Try the next one on your own. See if you can get B. Notice that's going by 2's here. This was like -2. Okay, what's my, is this shaded above or below? So what does that tell me about the sign?
It's going to be less than.
Do I need to put the or equal to? Yes, because it's a solid line. And now, okay, y-intercept, that's easy to pick out. Negative, yeah, that's right. Yeah, -5. And then the slope, okay. Well, honestly,
-4.
it might be easier just to do this, right? And because each box is getting counted by 2's, I can just use the boxes as my rise over runs. So look, rise 1, run 2. Oh, I'm purple. Come on. Rise 1, run 2. Is this a negative or positive sloping line? Negative sloping line. So this should be a -1/2. So y equals -1/2 x minus 5. And that's my answer. Questions about that? Okay. I'm going to stop the recording and then I'll bring up the